Hello learners, this is Mandla Nkomo, presenting Mathematical Literacy, grade 12. Our session will be based on the topic of measurement, and we'll be focusing on the subheading surface area and volume. We are going to focus on the three main concepts, which is the three-dimensional objects and the surface area and the volume. Let's look at the lesson objectives. The first bullet, explain the meaning of the terms three-dimensional models or objects, 3D, the surface area, the volume, the rectangle box, and the cylinder. You must identify the formula that you must use either for surface area or volume. The last objective, we must calculate the surface area and volume. Let's look at the glossary of terminologies. The first one is, what is a 3D object or a 3D model? It is a dimensional construction of real-life object. It is a solid. It has number one, the length. It has the breadth, and it also has the height. Then we go to the second explanation, which is rectangular prism or a box. It is a 3D object that has surfaces which are rectangles. It has the surfaces which are rectangles. The third one is a cylinder. A cylinder is a 3D also, which have congruent circles, two circles which are parallel to each other. So it is having circle 1, circle 2. You can see circle 1, circle 2, they are parallel to each other. Then you go to the surface area. The surface area of a solid object is the measure of the total area. It is a measure of the total area of other surfaces that the area occupies. Then the volume. The volume, it is the amount of a 3D space that is contained within an object or a solid shape. Let's focus now on the main topic for the matriculants, calculating the surface area of a rectangular box using the operational method. The operational method is a practical method, which is a little bit easier. Step number one, you break the three objects into basic shapes, such as rectangles, square, circle, triangles. Step number two, units must always be the same. The units must always be the same. That's what is important when you are doing surface area and volume. Step number three, you calculate the areas of the two opposite equal shapes. You calculate the areas of the shapes that are separated or disintegrated. Step number four, add the areas of all. You add all the areas of all when you are using an operational method. Let's look at one of the questions. Example number one, it says, calculate the surface area using operational method. So when you look at this, they say, calculate the total surface area of the given rectangular prism. Now, there's our rectangular prism. Leave your answer in centimeter squared. So our answer at the end must be in centimeter squared. You are given here a rectangular prism. When you look at this rectangular prism, it has the length, it has the breadth, it has the height. Let's look again when we are applying the operational method. Step number one, we said we break down the object into its basic shapes. So the first shapes that are there are the rectangles. Where are these rectangles? The rectangle is on the front, on this part, and the other rectangle is at the back. So these rectangles, it will be side number one and side number two. Then we look at the other part of the rectangular prism, which is side number three. Side number three, it is this side here, which is on our right-hand side, and we've got another side here, which is on our left-hand side. So we are having side number three and side number four. we are having again the two sides, which it is the bottom side and the top sides. When you look at this, it is going to be this bottom side here, which is side number 6, and we are having this top side here, which is side number 5. So we are having our rectangular prism operationally. So look at step number 2. It says the units must be the same. This is very, very important. Converting before substituting. So our candidates were encouraging you to convert. To convert when you are working this before you substitute. Before you substitute. This is a trick that makes exams to be a little bit easier. Do not substitute and convert in the formula. But number 1, convert, then number 2, substitute. Look at the conversion that happens on this rectangular prism. We are having here a side. There is our rectangular prism again. I will try it very quick. We are just converting this one, which is 0.82 meters. And this 0.82 meters, we are converting it using Majosi can do much dense hip hopping kwaito. Majosi can do much dense hip hopping kwaito. So when we convert the meters to the centimeters, what do? We just say there, we put our 1, our 0, our 0. Now you are moving which direction? You are coming from the meters, you go to the centimeters. What are we going to do? We are going to multiply. That's what we do. That's what happened on this calculation. We took that 0.82, multiplied it by 100. So we converted meters to centimeters. Majosi can do much dense hip hopping kwaito. We look at the second conversion. The second conversion, it's converting these millimeters to centimeters. Again, Majosi can do much dense hip hopping kwaito. We put our 1, we put our 0 here. So remember, our answer must be in centimeters squared. Now, what is happening here is that you look at that, we must convert these millimeters and convert them to centimeters. What do? We go this direction. When you move from the left to the right, you divide. You divide by which value? You divide by 10. So we are going to say 580 millimeters divided by 10. We have divided here by 10. Then we get 58. So it's 580 divided by 10. Then you get 58 centimeters. This one is correct. It's already in centimeters. Now we have converted all the units. We have converted all the units. Once we have converted all the units, we are having now again our rectangular prism. Our rectangular prism, whereby all the units are converted. So the first one is this one of 82 centimeters. We are having this one again, the other side, which is the length, which is 58 centimeters. And we are having the breadth, which is 50 centimeters. So once the units are the same, you are able to substitute. We are able to substitute because we have converted all the units to be the same. Centimeter, centimeter, centimeter. Now we calculate the area of one side. We calculated the area of one side. When you look at the area of one side there, whereby they take the area of side 1 here, the area of the first side. Again, our rectangular prism. So we are having the first side here, side 1. And at the back, we had side number 2. So when we get to the area there, we said the area of the first side, which is going to be equals to area, the formula there is equals to length multiplied by breadth. Then they just substituted there. They substituted with these values there. 50 multiplied by 82 is 4,100 centimeters squared. You can look at the units of area or of surface area, which is r to the degree of 2. Then they go to the second part whereby they say the area of side 2. Side 2 is the side at the back again, at the back side here, and the area of the first side, they are having the same area, parallel side. Then from there, we look at calculating the area which are opposite again for side number 3 and side number 4, the left-hand side and the right-hand side. We just use the same formula again, area equals to length multiplied by breadth. What we do, we substitute here the area of side number 3. So we expect our side number 3 to be the same as the area of side number 4. So the area that is given there, we get 4,756 centimeters squared or squared centimeters. So we take the area of side number 4. The area of side number 4 is equals to the area of side number 3. We look at the last areas now. Side number 5 and side number 6. What happens with the formula again? Area equals to length multiplied by breadth. In other formula sheet, you'll find that they say area is equals to length multiplied by the width, whereby W means the width. So the width, it depends whether you say width or you say breadth. For side number 5, we are going to say area equals to length multiplied by breadth. When you look at that area there, they substitute with 50 multiplied by 58, and you get 2,900 cubic squared centimeters. Then you get the area of side number 6, whereby it's 50 multiplied by 58, because these areas are equal, they are opposite and they are equal. Then from there you get the area of side which is on top and the side which is at the bottom. The side which is at the bottom. So this is number 5, this is number 6. Our main concept now. The total area of the 6 sides is equal to the surface area. So the total area of 6 sides is equal to the surface area. Now let me abbreviate surface area with our abbreviation SA, not South Africa, but surface area. So what is the surface area? The surface area here, the surface area is given by the area of side 1 plus the area of side 2 plus the area of side 3, area of side 4 plus the area of side 5 plus the area of side 6. So you take all these sides, you add the values there. When you look there in that formula there is the formula that you get for surface area when you're doing it operationally. Then we substitute there. Side 1, 4,100 centimeters squared. Then 4,100 centimeters squared. Centimeters squared. You add it to 4,756 centimeters squared plus 4,756 centimeters squared. Then you 2,900 centimeters squared plus 2,900 centimeters squared. It gives us a value of 23,512 centimeters squared. Calculating the surface area of a rectangular box now using the formula method. What is important is the formula. In mathematical literacy, paper 1, mostly the formulas will be given, or usually the formulas are given. In paper 2, formulas are given, sometimes they are not given. So when you are using the formula, step number 1, you choose the correct formula. Make sure that when you are given lots of formulas, you utilize the correct formula. Step number 2, the units must always be the same. There is our issue of the same units. Once the units are the same, your calculations are going to flow. Then you go to step number 3, you substitute, meaning that you replace correctly. You must substitute the right value on the right position. Step number 4, calculating, mostly using a calculator. When we calculate, we'll give you a little bit of complex values, then you need to use or utilize a calculator. We are calculating the surface area utilizing a formula. Here it's a formula for surface area that we are given. The surface area again, surface area, which is equals to 2 times length multiplied by breadth plus 2 times length multiplied by height plus 2 times breadth multiplied by height. So we have shortened the formula here by taking the first letters LB, LH, BH to create this formula. Now, what happens here? Converting, step number 2. Utilizing the formula, but we are converting. How did we convert? Remember in our figure again, in our figure that we did last time, what we did there, we said this one is 82 centimeters. We got this one, which is 58 centimeters, which is the length. And we've got the breadth, which is 50 centimeters. This one is given. But we converted this one when we were doing a operational method. Now we are using the formula method. We also converted this one. Now what happens with the formula? Converting all units to be the same. So the units are the same. So I said, convert first. You convert, then you substitute. Then you substitute. So in our formula there, surface area equals to 2LB plus 2LH plus 2BH. What is important now is that in step number 3, you must substitute correctly. The formula, remember you choose a correct formula. The second step, you substitute. The third step, you substitute correctly. Now let's look at the substitution here. Remember this is 82, which is the height. It's our h here. And this one is 58, which is the length. And we've got, which is the 50 centimeter, which is our breadth. So what we do, we just substitute that there. So you look at LB, the length, our length here. It is 58. So our length goes exactly here. Our breadth, it goes there. So it's just substitution. So 2 multiplied by 58 multiplied by 50 plus 2 multiplied by 58 multiplied by 82 plus 2 multiplied by 50 multiplied by 8. So the most important step here is to substitute correctly. You substitute, if you put that 58 in the, do not take the 58 and you substitute it with the height and you put 50 multiplied by 50 instead of 58 multiplied by 50. Already, the substitution is incorrect. Step number 4. In step number 4, calculate using a calculator. So simple, you just punch these values in your calculator, you punch this one again, you punch this one, you get your answer to be 23,512 square centimeter or centimeter squared. Look at the units again of surface area. The units for surface area must be to the second degree. Must be to the second degree, which is, can be millimeter squared, centimeter squared, meter squared, kilometer squared. These are the units that can be used to express surface area. There's some homework. Activity number 1. Calculate the surface area using operational method. Try to get a container or a page and you make it a cylinder. And leave your answer in squared meters and round it off to 2 decimal places. When you are doing operational method, you need to show the practicality. Now we go to the formula method. The same activity, they say calculate the surface area using the formula. That's what will be asked in the question paper. Sometimes they say calculate the surface area. Also leave your answer in meter squared or squared meters and round it off to 2 decimal places. Now what happens here is that we are given a cylinder. We are given a cylinder. We are saying now we are going for the steps now. We are having a cylinder, whereby in our cylinder, we are having a circle there. We are having another circle here, and our cylinder is having a line called a diameter. Our diameter is 5,200 millimeters. We need to convert this diameter. When we convert this diameter, we just say 5,200, we divide it by 1,000. Why do we divide by 1,000? Because we've got there Majosi can do much dance hip hopping kwaito. Focus on this one now, whereby they convert millimeters to meters. 1, 0, 0, 0. We are going to take it to this direction. And when we take it to that direction, we do what? We divide. We are going to divide. So 5,200 divided by 1,000, we are going to get it as 5,2 meters. We have done the diameter of our cylinder. Now we calculate the height of our cylinder. The height of our cylinder, M, C, D, capital letter M, capital letter D, capital letter H, capital letter K. We are converting what now? Majosi can do much dance hip hopping kwaito. We are converting centimeters to meters. Now we are having 1 there, 0, 0. Now what we are going to do, we are taking this, we are also taking it that side, we are dividing. We are going to divide that 105 divided by 100. This is going to be 1,05 meters. So we've got 2 calculations here. Here we've got 1,05. This one we've got 5,2. Same units? Yes, same units in meters and also in meters. That's the most important thing that we needed to achieve. After that, after getting this, what do? We are calculating the surface area now. Surface area of a cylinder. The formula for surface area of a cylinder is totally different from the formula of a surface area of a rectangular prism. Of a cylinder is going to be 2 pi r squared, meaning that it's equals to 2 multiplied by pi multiplied by radius. The r is the radius, all of it squared. So they will give you either of the formulas. If they give you either of the formulas, you can utilize the values. Now, what is happening here to get this surface area? We're just going to say this is equals to 2 multiplied by 3.142 as given in the CAPS document, the value of pi, according to CAPS in mathematical literacy, multiplied by the radius. What is the radius? Our radius now. Our radius whereby here we are having our diameter. To get the radius, we take this diameter, we divide it by 2. So we are going to say 5.2 divided by 2, which is equals to 2.6 meters. That is our radius, the value for our radius. So it's going to be 2.6 meters. All of it squared. We take the gadgets, that is very important in the exam. 2 multiplied by 3.142 multiplied by 2.6, all of it squared. 42.47984. But remember the question. It said in meters squared. That's where you get it right for the meter squared. But your answer, it is having 1, 2, 3, 4, 5. 5 digits after the comma. And they only needed you to round it off to 2 decimals. So we are rounding it off. So it's going to be 42, comma, because it's bigger than 5, it's bigger than 5. This one is going to be, comma, 48 by taking this one this side, meter squared. That is the surface area of this cylinder. Volume and capacity. This is one of the questions that was asked in one of the papers, national papers. Define volume, define capacity. Volume, it is the amount of space that an object occupies. Amount of space, just an amount of space that an object occupies. Capacity, the maximum amount. So we are having here amount versus maximum amount. So here we are having volume versus capacity. So in volume, it's amount. In capacity, it is the maximum amount. When we say something, it's full to its capacity. So, example, substances like liquid or gas that a container can hold. Look at volume here. I can say in this truck, when you look at this petrol truck, I can say the volume in the truck is either 4,500 here, and the truck is not full, or I can say the petrol inside the truck is 13,500 liters, while the capacity which this container can hold, the maximum capacity which this container can hold, it's 18,000 liters, this value. The tank has a capacity of 18,000. I'm not saying the tank has a capacity of 4,500, but I'm saying the tank has a capacity of 18,000. I'm looking at the maximum in this situation. Calculating volume, formula method. I'm not going to do this one using operational method. Now, when you are calculating volume, step number 1, you choose the correct formula. Candidates usually sometimes chooses incorrect formula. Make sure that you choose the correct formula. Units must always be the same. Make sure that you use the same units. Step number 3, substitute or replace correctly. Substitute in the correct space. Lastly, calculate using a calculator. Volume of a rectangular prism, and a volume of a cylinder. Look at the formulas that are given there. The formula of the volume for a rectangular container, its length, the volume there for a rectangular container, its length multiplied by breadth multiplied by height. So there is the length multiplied by the breadth, or the length is here, multiplied by the breadth, then multiplied by the height. So this is h here. So I can put my L also here. I can say this is my length, and I can say this is my breadth. Then some of the concepts, the way they are expressed, it depends on the deepness. If it's something like a dam, in a dam whereby there is a little bit of water there. So they look at the depth. The depth. Because the depth, it will show when it goes downwards. But if I'm going to a mountain, in a mountain, I will use the height. If this one is a river dam there, or a dam, this one is a mountain, the language for the concept will just change daily. So similar concept, only different naming there. Then for the cylinder, the formula for the cylinder, it is pi multiplied by radius squared multiplied by height. So the volume there is equals to pi r squared h. So it's pi multiplied by radius, that is the r there squared, multiplied by the height. Let's look at activity number 3. An exam type question. In an exam type question, they say there, Cinema was selling popcorns. The pictures below showed 2 different containers. What is important? 2 different containers, by just looking at the picture there, in which the popcorns are packed. Show with calculations which container will have more popcorns. So this type of a question, you must be understanding whether it is looking for volume or it's either looking for surface area. Now it's looking for the inner contents. They say, which container will have more popcorns? So for more popcorns, we are going with the concept of volume. And in this volume, we are going to look for a volume of a cylinder versus the volume of a rectangular prism. Rectangular prism. Now let's calculate the volume of a rectangular prism first. So they are not giving us number of decimals that must be there. They are not also giving us whether it should be left in meter squared or cubic meters. They are just saying, they say calculate there which one will take more popcorns. Now let me calculate the volume of a rectangular prism. The volume of a rectangular prism is given by length times breadth times height. Step number 1, correct formula. Step number 2, substitution. Make sure that the units are the same. Let's look at step whereby the units must be the same. Centimeter, this unit is fine. Centimeter, this unit is fine. Centimeter, this unit is fine. So I'm going to substitute for step number 3. Make sure that the substitution is correct. Where is our length in this situation? In this situation, the length is equals to the breadth. So you can put either of the values here. So you can say 12 centimeter multiplied by 12 centimeter multiplied by the height. The height differs now. The height is 24 centimeter. Then we go to our calculator now. 12 multiplied by 12 multiplied by 24. 3,456 cubic centimeters. To the 3rd degree. To the 3rd degree. Remember, what is this? It means that this is a volume. So volume can be expressed to the 3rd degree. The volume of a cylinder or a cylindrical container or a cylindrical container is equals to what? It is equals to pi r squared h. So what happens here is going to be pi multiplied by radius, all of it squared, multiplied by height. 3.142 again, as given by CAPS document, multiplied by the radius. What is our radius in this? We are given our radius in centimeters. 7 centimeter, all of it squared, multiplied by the height, 24 centimeter. Then we go there and we punch in our calculator 3.14, 3.142 multiplied by 7 squared multiplied by 24. 3,694.992 cubic centimeters. What happens in this instead? We look there. There is our formulas. Length times breadth times height. Pi multiplied by radius squared multiplied by height. And the units must always be the same. Step number 2, the units must always be the same. So the units are the same. 1, 2, 3, 4. These units are the same. Step number 4, substitute. Step number 3, substitute or replace correctly. So I'm replacing here the length, the breadth, and the height. 3.142 for pi as given by CAPS. 7 as given by the radius in the container. 24 as the height. Step number 4, calculate mostly using the calculator. Do not ignore the calculator. Utilize the calculator there. Then we get the value to be 3,456 and the volume for the cylindrical container 3,694.992. So we go to our conclusion there. The reflection, that is a level 4 question here. Cylindrical container will have more popcorns than a rectangular container. A cylindrical container, because this value is greater than this one. This one is greater. Or it's having more than this one. So cylindrical container will have more popcorns than a rectangular container. Recap again. When we come to the conclusion of our lesson, we are recapping. Point number 1, units for surface area are expressed to the second degree. Millimeter squared, centimeter squared, meter squared, and kilometer squared. Point number 2, units for volume are expressed using the third degree. Millimeter cubed, centimeter cubed, meter cubed, and kilometer cubed. What is important when you are doing surface area and volume? Make sure that you utilize correct formulas. Utilize correct formulas for both of them. Point number 4, conversion first. Conversion first, then substitution. I'm not saying substitute, then convert. Some candidates can substitute and convert later. But the best way to make calculations easier is to convert first, then substitute. The last bullet, 2 important shapes that you are going to meet for CAPS slit measurement under 3D. It is what we call a rectangular model and a cylindrical model. I thank you very much. Mandla Nkomo, it's my name.